Hello everyone, welcome to Don't Gasp. It's just JASP, your Learning Lab Tech tutorial. In this video, we're going to show you how to conduct a z-test using JASP. If you'd like to follow along, go ahead and use the CSV file we have provided on the Learning Lab website, and you can try to follow along with that. There is an earlier video showing you how to get that file running in JASP if you need to watch that first. But we're going to go ahead and try to conduct a z-test in JASP now. So our variable focus, we're going to say, is going to be weight. So let's assume all of our data is a sample of OSU students, and we're going to be comparing to the average college student in this example. So to run a t-test, you're actually going to have to go to the t-test section, and you're going to click on the one sample t-test. But once you get here, you're going to switch from student to z-test. This will have you run a z-test instead of a t-test. And then we're going to go ahead and drag over our variable of interest. We're going to focus on weight. And let's say that for our z-test, we know that the population mean mu for the average college student is 180 pounds with a standard deviation sigma of 25 pounds. And we just want to know if OSU students differ from average college students in weight. So that means our alternative hypothesis we're going to set to not equals to because it's a two-tailed test. If we felt that we're going to predict OSU students weighing more, we'd do a one-tailed test using the greater than sign. If we predicted OSU students would weigh less, we would do the one-tailed test with the less than sign. But we're looking for just a difference, so we're going to stick to a two-tailed test here. And then, if you'd like, you can also click on descriptives here, and it'll give you your n, your sample size, your sample mean, sample standard deviation, and standard error of the mean. That can be useful for helping you interpret your results. And then, if you'd like, you can check to make sure your data are normally distributed. It's one of the assumptions of the z-test. As you can see here, significant results suggest deviation from normality. So if our p-value is less than 0.05, that means it's significant. And significant means that it's not normal. So lucky for us, our p-value is greater than 0.05, which means that we've passed this assumption check and we know that our distribution is normal. You can click that off if you'd like. And then it always shows us our z statistic here immediately and our p-value. So we know that we have a significant result here because our p-value is less than our alpha, which we're going to stick with an alpha of 0.05, but it may differ depending on your instructor or what your aim is. But generally, we're hoping for a p-value of less than 0.05. So we know that's significant in the negative direction. So its negative direction tells us that the OSU students weighed less than the national average mean. If we want to see our Cohen's d, our effect size, you click the effect size button, and you will get your Cohen's d value. Remember, sign doesn't matter for Cohen's d, it just tells you direction. We care about magnitude, so we have a Cohen's d value of 0.675, which suggests a relatively large effect. Again, check your instructor and your textbook for specific ranges on Cohen's d because interpretations may differ. And that's all you really need to know for conducting a z-test in JASP. Very straightforward process and requires much less tedious calculation by hand than you're probably used to for class. It's a great tool once you know how to use it. That's all for this tutorial. Remember, stats are whack, but we've got your back. Have a wonderful day.